against Dr. Ajibola also used this word. The topic of physics, that is wave. What is a wave? A wave is a disturbance which travels through a medium and transfer energy from one place to another without causing any permanent displacement of the medium itself. Again, wave is a disturbance which travels through a medium and transfer energy from one place to another without causing any permanent displacement of the medium. Full stop. Now, example of wave, we have light, gamma ray, X-ray, sound wave, radio wave, etc. They are example of wave. Now, the first thing you have to know about this wave is that you have to know the terms used in wave. Number one term is what? Medium. I mentioned the medium, medium is very important. What's medium? Medium is what? It is the physical environment through which wave propagates. Again, the physical environment through which wave propagates. That is the medium. Number two, we have the period. What's the period? Period is a time taken for a wave particle to complete an oscillation. The time taken for a wave particle to complete an oscillation. Now, it is expressed mathematically as T is equal to what? T over N. The time to complete an oscillation can also be written as well. T is equal to what? 1 over F. So these are the two major formulas we use to calculate the period of a wave. Number three, frequency. What's frequency? This is the number of waves produced per second. Number of waves produced per second. So it is N over T. Can also be 1 over T. These are the major formula to calculate the period and the frequency. Number four, the next one is what? Amplitude. What is the amplitude? Amplitude is what? The maximum displacement of a wave particle from the equilibrium position. Now, this is the equilibrium position. The maximum displacement, it is what? Amplitude. So, amplitude is what? Maximum displacement of a wave particle from where? Equilibrium position. That is the wave amplitude. The next one is what? Wavelength, number 5. What is wavelength? There are different definitions for this wavelength. Now, the first one is what? It is the what? The distance between two successive crests or two successive troughs of a wave train. Now, suppose you have a wave traveling like this with different crests and troughs. The top here is a crest. This is another crest. This is another trough. The down here is trough. Now, this is a crest. The distance between them is what? A wavelength. This is another trough. This is another trough. The distance between the two is called a wavelength. That is the first derivation. Again, the distance between two successive crests or two successive troughs of a transverse wave train. Then it can also be defined as what? The distance covered to complete an oscillation. Now look up. From here, this is half of oscillation, while this is a complete oscillation. So the distance covered here is called wavelength. That's the second term. The third one is what? The distance between refraction and compression of a longitudinal wave. The distance between refraction and compression of a longitudinal wave. That's the third definition of wavelength. And it is also measured in what? In meter. Then number 6. Wave speed. It's like other speed also. Wave speed is what? The distance covered by the wave particle per second. The distance covered by a wave particle per second. It is measured in meter per second and expressed mathematically as the first one is what? V is equal to what? F lambda. That is the first definition. The second definition is the first formula. V is equal to what? Lambda over T. The first one here is to calculate speed in terms of frequency and wavelength. What this one is to calculate the speed in terms of what? Wavelength and what? Period. The next one is what? You have to know number 7 is node. Wave node. What is a node? A wave node is a point where there is no movement of the medium. Now, from this point now, there is no movement of the medium. This point also no movement of the medium. No movement of the medium. So those points are called nodes. A point where there is no movement of the medium is called node. The next one, number 8, antinode. Now, before we move to antinode, now the distance between two adjacent nodes, this one and this one, is known as N1, N2. It is half of a wavelength. Know that. You have to note it. The distance between two adjacent nodes is what? Half of a wavelength. Number 8. Antinode. What is an antinode? An antinode is a point where there is a maximum displacement of the medium. A point where there is what? Maximum displacement of the medium. This point is what? Antinode, antinode, antinode. That is where there is maximum or minimum displacement of the medium is called antinode. Number 9. Wave front. What's a wave front? A wave front is a line or section through an advancing wave where all particles are in phase. Again, a wave front is a line or section through an advancing wave. An advancing wave means what? A wave that is moving, spreading out, where all particles are in phase. Take for example, if you throw a stone into the water, you see something that is forming in sections. Can you see now? Particles along each section now. This is a section now. Particles on this one are in phase. Particles on this one are also in phase. So now this is one example of a wave front. It is an advancing wave where particles are said to be in phase. Why the particles are in phase? Because they have the same distance from the point of the surface. That's why the particles on each circle are in phase. Why? Because they have the same distance from the point of the surface. So this is a typical example of what? Wave front. We have what? Refraction. The next aspect is what? Is refraction. What's refraction? Refraction is a point on longitudinal wave where there is maximum displacement of the medium. Maximum displacement of the medium. Then number 11 is compression. A point on longitudinal wave where there is minimum displacement of the medium. So the medium are compressed. That's why we call it compression. So you get. So these are the terms we use. Then the next one is number 12, phase. That's another one you have to understand very well. So particles are said to be in phase if they have the same distance from the point of disturbance. So particles along this line or this circle, they are in phase. Why? Because they have the same distance from the point of disturbance. While particles along this circle also, they are also in phase because they have the same distance from the point of disturbance. These are the major terms we use in waves. Then let's go to types of wave. Types. Fundamentally, there are two types of wave. Two types. Number 1 is what? Mechanical wave. What's a mechanical wave? What do you mean by mechanical wave? A mechanical wave is the one that requires material medium for its mode of propagation. A mechanical wave is the one that requires material for its mode of propagation. Example, water wave, sound wave, wave generated from string and rope, wave generated from string and rope. Number 2, electromagnetic wave. What is an electromagnetic wave? This is the one that does not require material for its mode of propagation. It does not require material for its mode of propagation. Examples include gamma ray, X-ray, ultraviolet, visible light, and infrared and radio wave. The example of electro. These waves, they do not require material, they do not. They can travel they can travel inside the cube. They can travel in a free space, and they also travel with the speed of light. So that's why we call them electromagnetic. They are produced as a result of the vibration between magnetic and electric field. So example are gamma ray, X-ray, ultraviolet light, infrared and radio wave. And look up, they are the acronym is what? Garcilia. So the first one is what? Gamma ray, followed by X-ray, followed by ultraviolet, followed by light, followed by infrared before we have what? Radio wave. Gamma ray. These one are the what? They have the greatest penetrating power or the shortest wavelength. Greatest penetrating power. What's not greatest penetrating power? Which means they can penetrate through many materials. They can pass through blood, bricks. That's why they use them to cure cancer and tumors. X-ray. These are produced. They are produced in the X-ray tube. The major things under this one is also a topic on its own, but we just want to mention them here, not that we are treating them. X-ray are produced in what? X-ray tube to sterilize medical equipment, to discover hidden weapon in luggages, to do other medical, to discover the floods, and to do other medical things. Ultraviolet is also parts. Visible light, infrared and radio wave. They are just examples of what? Electromagnetic wave. EM wave. Electromagnetic. Then classes of wave. Number 1, we have transverse. What are transverse waves? Transverse waves are waves. Transverse waves, they are waves. The direction of propagation is perpendicular to the vibration of the medium. Again, transverse waves are waves that their direction of propagation are perpendicular to the vibration of the medium. Examples are water wave, wave generated from string and rope, wave generated from string and rope, water wave and wave generated from string and rope. Number 2, the next one is what now? Longitudinal wave. What are longitudinal waves? These are waves that their direction of propagation is parallel to the vibrating medium. Again, waves that their direction of propagation are what? Parallel to the vibration of the medium. E.g., sound wave. They are example of longitudinal wave. Now, the next one is what? Number 3, stationary wave. It's also a class of wave. Stationary waves are waves produced when two simple harmonic waves of equal in amplitude and frequency are traveling in opposite direction. Again, when two simple harmonic waves of equal in amplitude and frequency are traveling in opposite direction. That is what we call, they are traveling in opposite direction. That's what we call stationary wave. So before we have stationary wave, there are conditions for stationary wave to occur, number one, there must be a medium. Number two, the wave traveling must have equal amplitude and frequency. They must have equal amplitude and frequency. These are the two conditions that will satisfy stationary wave. Another name for stationary wave is also called standing wave. Standing wave. Number four, progressive wave. What are progressive waves? Progressive waves are waves that are produced when the wave travels or the wave travels continuously. E.g., wave generated from a string tied at one end. So it will produce a kind of wave that will move for a long period of time. That is what we call progressive wave. It's a wave that travels without an end. It's called progressive wave. Another name is what? Continuous wave. So these are what? Examples. These are what? Classes of wave. Then the next one we have to know is properties of wave. Or you call them characteristics of wave. Or characteristics of wave. The properties are called characteristics. Number one is what? Reflection. What is reflection? Reflection is what? It is a bouncing back or throwing back of wave when it meets an obstacle with minimum absorption. Again, reflection is a bouncing back or throwing back of wave when it meets an obstacle or a barrier with minimum absorption. So when a wave hits a barrier with a minimum absorption, it will travel back. The movement of that wave is what we call reflection. Shall you get? Now, number two is what? Refraction. What is refraction? Refraction is what? Refraction of wave occurs. Refraction of wave occurs when it travels. This one is reflection of wave. The second is what? Refraction of wave. Now, refraction of wave occurs when it travels from one medium to another. When a wave travels from one medium to another, so it refracts, which means it bends. Why is it bending? Why is it bending? Because, number one, the wavelength of the light or the wave coming from one medium to another, the wavelength is not the same in the two media. Number two, the speed is not the same. Number three, the density of the wave is not the same. That is why it refracts. The only factor that is the same is what? It is the frequency. So, a typical example of this refraction is what? A light wave. When a light is traveling from air to glass or water, it bends or refracts. So, if it's traveling from less dense to a denser, it bends towards the normal. But if it's traveling from denser to less dense, it bends away from the normal. The next one is what? 3, which is what? Diffraction. What is diffraction of wave? Diffraction of wave is what? Bending of wave. Bending of wave through small openings or gap. Again, bending of wave through small openings or gap in the same medium. This one is also bending of wave, but in different medium. While this one is the same medium, bending of wave through small openings or gap in the same medium. And when you see something like this, we have a slit. Wave that is traveling. When you see something like this, it will bend, squeeze, now form something like this. So this phenomenon drawn on the board for you is called diffraction. It's called diffraction. Can you see the wave that is coming? When you get to this thing, it tries to squeeze and what? Spread out. So this process is called diffraction. Number 3. Number 4. Polarization of wave. This is the confinement of transverse wave in one direction. Polarization. This is the confinement of transverse wave. Confinement of transverse wave in one direction, which means it affects only transverse wave, not longitudinal wave. That's why we say it is confinement of transverse wave to allow a transverse wave to travel in a particular direction. Method of polarizing light. So a typical example of polarization is what? Light. Light can be polarized, can be made to travel in a particular direction. While sound is a longitudinal wave, cannot be made to travel in a particular direction or cannot be polarized. Sound wave or longitudinal wave cannot be polarized, but light wave can be polarized. What is polarization of a light? Now, we have a rule that we call Malus rule. When a light ray falls on a surface, when a light ray falls on a surface like this, this is the incident ray. Incident ray. There is an angle here. Now it reflects. This is a reflected ray. Now, this reflected ray, it will be polarized or it will be plane polarized if this angle is 57.5. But if the angle is not 57.5 degrees, the reflected ray is not polarized ray. It's not a polarized ray. So this is how to produce a polarized wave. So method of polarizing a light. Number one, by reflection. We can take for instance now, for this one is by a polarized wave can be produced by reflection when the angle is exactly 57.5. So a polarized wave can be produced by what? By reflection. Number two, by refraction. Number three, by scattering. Number four, absorption of crystals. So these are the ways we can polarize wave. It's very light wave, it can be polarized. So we call it method of polarization. The next one is what? Application of polarization. Where do we apply polarization? Application. Number one, in polarimeter. In polarimeter, it is used in polarimeter. Number two, it is used to reduce glares. Number three, it is used in sugar concentration. Number four, it is used in liquid crystal display. Liquid is LCD. Most of us will have it on our phone, where you have to the touch lights. You see the right LCD there. That is liquid crystal display. It is application of what? Polarization that is used there. Then the next one, number four, of characteristics or properties is interference and superimposition. Superimposition/interference. What is superimposition of wave? Superimposition of wave is what? Is the principle of combining two or more waves with the same or different frequency. Again, superimposition is the principle of combining two or more waves with the same or different frequency. The principle of combining is what? Superimposition. When two waves when they travel together with irregular frequency, so superimposition is the principle of combining them together. While interference is what? Interference occurs when two waves travels together in the same medium. When two waves travel together in the same medium, and this interference is divided into two. The first one is what? Constructive interference. What is constructive interference? It occurs when two waves travels crest for crest and trough for trough, as it is drawn in diagram. Look up now. This wave one, this wave two. The crest of the crest, trough of the trough, crest of the crest. So look at it. The crest of the first wave and the crest of the second wave are traveling together, while the trough and trough are also traveling together. In this kind of wave, we call it constructive interference. And the antinodal line for maximum constructive interference is equal to what? 360 degrees. The antinodal line for maximum constructive interference is what? 360 degrees. Then the second one is what? Destructive interference. Destructive interference. This occurs when the crest of one wave is seen on the trough of the other wave. So when they have diagram like this, it is under destructive interference, or we call it cancellation. Cancellation. So this one gives a maximum resultant. Why this one gives zero resultant? Because it is called cancellation. So when the trough is seen on crest on trough, it is what? Destructive interference. And the antinodal line for maximum destructive interference is 180 degree. Antinodal line for maximum destructive interference is 180 degree. Thank you for listening to me. God bless you.